let's keep going. So next we want to look at the normality of our data. That is, whether the responses that we've received in the survey are representative of the general views of the population. So the normality curve is the best way to test normality because it will show the data on a graph, allowing you to visualize where the responses are overall using statistical averages. So what we're going to do is we're going to take the aggregate or the sum of our 4 reasons, and we're going to analyze the total delay reason item. And so if you recall, each one of these reasons is on a Likert scale from 1 to 7. So the maximum value of our total delay reason will be 7, 14, 21, 28. So this is essentially a range from 4 to 28, right? Because you can't have less than 1. So 1, 2, 3, 4 as a minimum, or 28 as a maximum. The higher that number, the more that they've specified those problems as reasons why the bus was late. So let's go into analyze, descriptive statistics, and frequencies once more. And here we're going to take our total delay reason variable and move it into the variables box. Next, I want you to choose statistics, and we're going to select the 3 measures of central tendency, mean, median, mode. We're also going to choose the minimum and maximum. And this time, we're also going to include skewness and kurtosis. And then hit continue. Next, I want you to choose charts. We're going to include a histogram. You've learned about histograms in a previous video. In this video, I'm going to show you how the normal curve impacts or reflects the normality of the data on that histogram chart. So select the box, show normal curve on histogram, and choose continue. Keeping all other details the same, I'd like you to hit OK. So here we start with our statistics box to show that we had 120 responses, 0 missing. Excellent. These are the indicators here. So 17.2083 was our arithmetic mean. Essentially, if we take all of the data, all of the responses for the total delay reason, add them up, and divide by 120, we would end up with an average of 17.21. Remember, this is out of 28 in total. The next number, mode, is the most frequently occurring. The median is the exact middle number. So very similar to one another. So that's an important point I want to make here, why I'm showing you the central tendency. 17.2, 17, and 18 are all quite close to one another. Next, I want you to look at this new this new statistic. It's called skewness. So skewness essentially tells us whether the data is over or underrepresented within the data set. So in other words, do the responses skew more towards the lower numbers in the Likert scale or more towards the higher numbers in our Likert scale? That is, are people identifying 2s and 1s and 3s on the scale of 1 to 7, or are they choosing 5s, 6s, and 7s? Because that will tell us whether people are noting those all of these as reasons for the delay of the bus. So we would like a skewness value of between minus 0.5 and positive 0.5 to say that the data is normally distributed. In other words, we don't have skewness in the data set. Here we're close. We have a negative 0.409, but because it's within our range of negative 0.5 and positive 0.5, we would conclude from this statistic that our data is normally distributed. That is not skewed. The next value is kurtosis. Kurtosis is the height of the line. So that is basically indicating whether people are responding to a single choice more than all the other choices in the data set. If everybody chose 3, for example, we would say that our responses are quite kurtosis. In other words, there isn't a lot of variation in the responses of our data set. And therefore, there might be a problem with the way that we collected that data. If everyone says the same number, what's going on? Why don't we have a more accurate representation of the people who take that bus? So here our kurtosis value is closer to 0 at 0.092 than it is to zero point 0.5 or negative or positive. So we can say that this value is very normal. In other words, there's a very, very strong range of responses from our respondents. Remember, the closest we are to 0 with our skewness and our kurtosis, the more normal that curve will be. So without even looking at the histogram, I can conclude from these two values that our data, our curve and our line is going to follow a very nice bell shape. This table here gives us a breakdown of each response sum and how many were given for that. So if we're following a normally distributed data set, we should see it starting at low frequencies, working its way slowly up to higher ones, peaking around the midpoint, and then coming back down again on the tail end. So this is a nice way to look at that in a table form. However, the best way to view the normality or to test the normality of the data is to refer to the histogram. So here we have a histogram indicating our mean, our population size, and I will show you coming up what the standard deviation represents. But look at the curve here. You can see that it's a very nice steady curve up and then back down on the other side. There is a bit of a lean towards the right-hand side. So this data does have a slight indication of being negatively skewed. However, because that value was less than 0.5, you cannot conclude that the data is indeed skewed. So this is a normal uh, set of measurements.